Alright, once more I am live for Odinmade Hero, a series where I do my best to follow Casey Muratori and learn how to make a game one day at a time. Yesterday was a bit of a fumbling. All I was trying to do was add full screen and do cursor hiding, mouse cursor hiding, the same way Casey was doing it with the Win32 API, but I was doing it with STL, and so that kind of led me to discover that some code that I thought was working was not working. It also made me kind of reevaluate how I was handling the acquisition of window dimensions. I had originally implemented this get window dimension proc, and it was calling this get window position proc from the STL library along with get window size over here, and one gets the position of the window in the monitor, right, or the offset X and Y, and that's get window position. Get window size gets like the actual dimensions of the window, right? So I was kind of blending these two together in one window dimension struct, and I just decided that that was bad, and wrapping these calls into one that gets stored in some struct that I'm defining myself just doesn't need to be done. So now I'm just using STL's rect struct and trying to just use the get window size and get window. In fact, it looks like I'm only using get window size in one place right here. I'm only using the get window size and get window position procs where they're absolutely needed. And I think that works better. So I got to go and update my separate platform layer repo because I just really didn't like the way that was working out. Is creating a weird issue where, and this leads back into where I immediately left off from at the end of the last stream, which is trying to get the full screening to work properly for the game when we go ahead and run it. There were two things going on. The Alt key press was not registering for reasons that I didn't understand. And one thing I discovered after I had, quickly implemented the full screening was that when stretching the buffer out like so over the entire window, once we go into full screen, I was getting some weird kind of, I don't even know how to describe it. Like there was some weird clipping of the buffer that was left up in the top here. And I didn't like that. I didn't understand why that was happening, and that's what led me to discover this issue where basically, because I was bundling the window dimensions into this X and Y and width and height struct, when copying or not copying, but when passing that dimension in for the full screening, because now I have this conditional here that says basically if the window size that we have is greater than 2 times or more the buffer's width and height, then we just go ahead and draw the buffer out to the entire window dimensions. In case he does this a little bit differently, he actually draws it out to be exactly the dimensions of the buffer width and height times 2, but I'm just stretching it out over the whole thing because I don't really care. I can understand how to change it back if I'm so inclined, but I wanted it to go over the entire screen like so because that's what his does, but he's on 1080p and I'm on 1440p, so I just wanted to be able to see that stretched out nicely across the entire window. But the point is I was making that call to get both the window size and the window position, and those were getting bundled into the X and Y, so it was drawing the buffer offsetted by 10 X and Y or whatever, and it was creating that weird issue. So once I realized that was like the wrong thing to do. I should never have implemented that. I should have just called these straight out wherever I needed to, and then dropped in the rect like so. We still, if we're in not full screen, I just use the rect off of the buffer the same way I was before, And that's because, you know, we have this little offset in there that we want to preserve so that we can see if we're actually drawing things correctly. I can't remember exactly how Casey articulated that, but basically you can see that inside of our window in the top left here, the actual texture buffer that we're writing to is offset in just a little bit. So that was basically being preserved here when we were in full screen, which we didn't want. So I think I'm okay with this. This pretty much mirrors what Casey did as closely as I can do it in STL. And then I think that this rect here, it might have always been an STL rect, but I think, yeah, I think that always was an STL rect. But now I'm not dealing with that unnecessary window dimension type that I had added. So that was that. And then the Alt key thing was a little weird. So this was the only check I had to see if the key modifier that was currently down was keymod alt. But it turns out there's these two others, L alt and R alt, which actually map to these keymod flag bit sets, you know, one corresponding to left alt and right alt. It's just a bit strange. Like, I would have liked to have done something like this, which you can do with bit sets, but not in this context, because this is a key mod and this is also a key mod. So it's like, I can't ask if one bit set is in another. It would be more appropriate, I think, if this member of the keysim struct was actually, in fact, maybe this was what I was looking for. Sim, but that would be keysim.sim. So actually, now that I'm looking at this, that might be the right thing. Perhaps. I guess I could go ahead and try it. If I look at mod here, we have key code and key mod. Actually, no, that's not right. Yeah, because that's not the modifier. That's like the actual key code for the key that's being pressed. Yeah. Yeah. So I can't do that. But what I can do is also check to see if it's equivalent to either of these. And so basically what this check was doing is it was only assigning alt key was down to true if I had both alt keys pressed on my keyboard. So I never bothered to try that because I would have thought that pressing just one of them was enough. But now whether I'm pressing the left one, the right one, or both, and pressing enter at the same time, we'll get that in and out of full screen. So that was that. And then down here, you know, we just check, okay, if alt key was down and the return key is down, we toggle full screen. And then instead of having it toggle to true or false inside of this conditional, I just swap, you know, whatever the value is outside after we've set the window to either be full screen or not to be full screen. So nothing too crazy. It really shouldn't have caused as much confusion and complication as it did, but at one point going full screen just kind of blew up OBS and it wasn't doing the right thing anymore. So I just, you know, oh no, why am I recording too? Stop recording. I don't know how that happened, but I think it's fine. I don't care to record it because these VODs just go straight to YouTube. So maybe I'll care to record them someday, but for now I don't want all of that memory just getting taken up in my machine for no good reason. So that's where I'm at. We're going to jump right into day 42 of Handmade Hero, because day 41, we left off at the end of day 40 yesterday, on yesterday's stream, but on day 41, Casey just goes into you know, very high-level descriptions of all the math that are involved that you can come across in games programming. And so that was just a lot of whiteboarding, and so I just listened to that and watched parts of it earlier today during my workday while I was you know, doing some code review and taking care of some other stuff. So we're caught up to day 42, and it's worth it if you care at all about that sort of thing, but I wanted to take the time today on stream to actually write some code, so that's what we're going to do. So with all that out of the way, Casey can take it away.
And start recording. Okay, Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on the air from scratch using nothing, no libraries, no engine, so that we can see how absolutely everything in a game pipeline works, right down to the pixels and all the way up to the high-level game code. And right now we are working on what is essentially going to be our primary character movement code, and so I really wanted to be able to kind of start using the basic sorts of math that we use in game development, just basic vector math, that sort of stuff. I wanted to start using that, but we had not actually covered that yet on the stream, and so last night I kind of gave a little bit of a math overview to sort of say what types of math are involved in game development, and tonight we're going to do our first kind of like experimentation with some of that math. I'm basically going to show how to use 2D vector math, just trying to give you the background of basically how it works, and show you kind of how we use it to allow a character to move around, that sort of thing, and that will kick off our work on getting some good character movement into the game. Now, before I go any further into detail on that, if you would like to follow along at home and you pre-ordered the source code on handmadehero.org, you should have gotten a link in your email where you can download the source code. And if you take a look in that zip, it basically has they're coded by day. You can basically grab the zip for day 41 and unzip it, and you will be exactly where I am today. Now, of course, you can also grab the zip for day 40 since we didn't do any coding yesterday. It was just a math overview day. But for completeness sake, I still upload a zip every night. So there is a day 41 zip. It's the same as the day 40 zip. Anyway. So let's go ahead and get started here and take a look at this stuff. I will go ahead and I'm using the pen. I'm seeing if I can use the pen instead of a mouse since I was using it for drawing, and I feel like I might have to draw diagrams and stuff. So we'll see. It may come to a screeching halt if I decide that it's too much of a pain, but we're going to try it, maybe at least for one episode. We'll see if I can get used to it. All right, so basically, if you remember correctly, this is where we left things, where we had done a bunch of work on basic stuff. We tested scrolling. We allowed ourselves to make a tile map that could be huge, and so we did sparse tile map storage. We did a bunch of stuff, but we got to the point where we need to start thinking about moving our guy around. And right now, our guy has the worst movement code ever. It's the most basic, most annoying movement code, and I'm not even talking about the animation. I'm not even talking about the fact that he doesn't animate yet, because that's something that we want to fix as well. But I'm even just talking about at a much lower level than that, which is just the act of moving him around doesn't feel very good. And there's a number of reasons why that is true. Some of which are going to be obvious to people who've worked on games before, but if you haven't worked on games before, they may not be obvious to you. You may just kind of notice that it just doesn't feel good. And one of the big ones is the character doesn't have any momentum at all right now, right? So if you see, basically all that's happening is when I push down on the keys, really he just moves while I'm holding down the key at a resolved rate, and then as soon as I let go of a key, he just stops, right? Furthermore, it's got some oddities in it. For example, if I'm going right, I go at a certain speed. If I'm going down, I go at the same speed. But if I go right and down at the same time, I actually go at the combination of those two speeds. So I basically go the full speed to the right and the full speed down at the same time, right? And so that's also kind of another weirdness, because it basically means that on the diagonals, the character moves at sort of an accelerated rate, which is also kind of weird. So there's a number of things about that are unsatisfying. If I go up our kind of virtual ladder there and go up to the sort of next layer of the tile map here, also you will note that when I kind of go through a doorway or something like that, if I am going through them the long way, I'll speed my guy up here so I can kind of go up somewhere that has a doorway going upward, which is what I want to show you. I get sort of another really annoying thing that happens that we want to look at eventually, and this is kind of a little further down the road, but just to underscore how bad the player movement code is right now, I get stuck on just about anything. Like I can get stuck right there. It's really hard for me to get through this doorway, right? It's really annoying. Any little misalignment causes me to stop entirely. And so basically there's just a lot of things that are really lousy about this player movement code, and all of those are things that we want to improve. So there's that. And then, of course, on top of that, what we want to do is we want to make it more interesting for the player to move their character around, because moving their character around in a game like this is something they're doing all the time. They're always moving their character around on every single screen. They're moving from left to right. They're dodging enemy shots or whatever they're doing. They're moving the character around as a primary operation that they're going to do. And one of the things that ends up happening, if that's the case, is you want to provide a lot of good visceral feedback, basically, while they're moving around, because that's one of the things that will make your game engaging. Like, I mean, at the risk of stating the obvious, one of the things that's crucial in making a video game is making good audio-visual feedback for everything. And a lot of people will say stuff like, it's all about the gameplay or whatever, but those statements are kind of nebulous, because we all know that a video game is different from a board game in that there is audio-visual feedback. That's what makes it a video game. And so a lot of what you're trying to do in terms of making the game fun and engaging, yes, there's a ton of stuff that's important in terms of game mechanics and all of the stuff that exists one level up from the pure audiovisual feedback. But at that base level, the audiovisual feedback is really what makes the game immediately engaging, and is what allows the players to be interested enough in playing the game to get to those deeper things that you're putting in there in terms of your game mechanics and whatever. It's what allows you to get to the next step of design in terms of interest. Otherwise, you just have a game that feels awful to play, that maybe if someone's willing to suffer through the awful feel, they will discover the fact that you designed it well, right? And so it's really crucial that we avoid that as well. So what we want to do is make it really fun to move the guy around, so we want to make him feel really nice. And you can see he's a little fellow that doesn't have any arms and legs, and so one of the things that we'll want to do is kind of make him have a nice kind of hop. I want him to basically be able to hop around and have that hopping feel really nice, instead of right now it just feels really boring and uninteresting, right? So that's our goal over the next however many days it takes, as we sort of learn about how to do our vector math, is I'm going to basically be showing you how to do basic vector math through the lens of improving this guy's motion, so that he is able to move in a smooth, satisfying way for the player, and so that his the visual feedback that the player receives while the character is moving is very engaging and satisfying, and makes you want to do it. It makes you want to just move him around, like it just feels really good. And so that's basically where we're going with all of this. Okay, so let's get started with some basic stuff. Let's get started with that first thing, which is the very easiest thing to fix, that momentum problem that I was talking about before. I was saying that he doesn't have any momentum, he just stops on a dime and he starts at full speed, right? So let's fix that momentum problem, and while we're at it, let's take a look and see if we can fix the fact that he moves faster on the diagonals than when he's going up, down, left, and right alone, right? And so those are things that if we learn some basic vector math, we can solve very easily. So let's go ahead and do it. All right. So the first thing I want to talk about is just for the people who are very, very beginner at this sort of stuff. I just want to kind of remind everyone what we're talking about when we talk about vectors. So basically, you've already seen in the code, right? If I load up the Handmade Hero code base here, and I go in here and look at my handmade.cpp, this is the code that we were using to move the player, right? And as you can see in here, we basically were saying, all right, we want to pick a new position for the player. We want to basically take his old position, which is what we're doing here. We're going to assign it to a temporary variable, and then we're going to add to its offset x and offset y, which is basically how far he is away from the center of whatever tile he's on. We're going to go ahead and add however much time has elapsed for this frame, or is supposed to elapse over the course of this frame, I should say. We're going to take whatever his motion is in the x direction, we're going to multiply that and add it to the offset x, and we're going to do the same thing for y. Now, if you take a look at what happens here, you will notice that this sort of thing tends to be very common across a lot of the stuff that we've already written. You will notice that the x and y tend to be handled together in a number of ways. They're both getting multiplied by player speed here. They both get set to 0 here. We do the same thing to all of them here as well. And similarly, if we go into Handmade Tile, which still is holding some of our stuff we weren't sure exactly where to put, if we look at kind of what happens in here to offset x and offset y, you'll also see stuff where a lot of times those get processed in the exact same way. You can see them getting processed in the exact same way here. You can see them getting processed in the exact same way here. So a lot of times you just get this sort of pattern that you would see if you didn't know anything about vectors, you didn't know anything about the math behind it or anything. You would start to see this very clear pattern in your code where you're constantly doing the same stuff to pairs of variables, your x's and your y, the horizontal and the vertical movement. And that is really where this notion of vectors in game development come from. It's the reason that we start turning to vectors is because we do start to have a lot of variables whose behavior is interrelated. They are not really separate anymore, right? They're always handled together, and they form sort of a coherent notion in and of themselves, such that if we start to look at all the operations that we perform on them, we will find that we can boil those down to a set of basic operations that make it much easier and much faster to work with them. And it just so happens that obviously mathematicians beat us to this concept a long time ago, and have already defined all of the sorts of stuff you might want to do with vectors, and already worked out kind of everything for us. And so really that is what this sort of vector stuff, in terms of why we care about it, that's really what it boils down to, is we have a bunch of operations that we're going to constantly do with this notion of points and directions and stuff that have both x and y and potentially z components to them, and we want to start thinking of those as coherent things that have operations on them that make sense as a unit, right? And so you'll note, actually, this is a good point here, one of the reasons I didn't want to fix this diagonal movement problem, remember I was saying the thing about the diagonal movement I wanted to wait, is because that's a perfect example of when the actual coupling between the objects, between the x and the y, starts to be important, right? It's no longer something that's handled in isolation, so it starts to be something that's about the actual combination of both the x and the y at the same time. And so what we could do, to start off, to give sort of an example of what's going to happen there, is you could think about what we actually want to have occur, and we can sort of back out maybe into what we're going to do based on sort of thinking about it a little bit, right? So if I were to draw, again, not even talking about vectors yet, right? Not even saying the word even. If I were to draw what was going on,
we're not going to say the word, but we said the word like 5 times. I am actually really excited for this because this is like a killer part of using Odin for me, is this idea that working with vectors and using array programming to make working with vectors really easy makes it really easy to work on game code and particularly working with graphics. So it's exciting. I did already make my own vector types. I think I stored them in the tile file right up here. So we're gonna be using these quite a bit and replacing a lot of these spots in here where there's an x and y decoupled. We want to couple those together because they're always going to be together, and that's really all he's driving at this point.
Then in that diagonal case, right, we were basically saying, okay, the guy's here, and we know that he has some amount of x motion that's going to happen over this frame. So over the course of one frame, right, and that's this code right here, right, input dt for frame times player x, the offset x, I'm adding. So I'm adding this right here. That's this quantity, right? If I'm going to add that, and then I'm also, it turns out that he has a d player y, I'm also going to add that to his offset y, which is this, of course, right? So I'm also going to add something that's moving him the same direction this way, right? And so if I wanted him to move at a constant rate no matter what direction he was going in, I wanted to make sure he never exceeded that, right? Well, you can see the problem with what I'm doing here in terms of getting that result. We're going to add both of these together, so the combined motion, right, if you think about where it's going to end up, is going to be here, right? And how long is that vector? You can kind of see if I rotate it up to here, right, if I do like a rotation, it's longer than either of these two vectors. And it's longer because it's involving the contribution of both the x and the y at the same time, right? Now, it's not twice as long, okay, but it is longer, okay? And exactly how long it is something that we'll talk about in a second. Okay. And you may ask yourself also, why isn't it twice as long? And the reason that, of course, it's not twice as long is because he is not actually, as far as the viewer is concerned, right? here's one way to think about it. The path that he took is in some sense twice as long. He walked this way for that length, right? Because remember, these are both the same length. And then he walked this way for that length. That's essentially what I had him do, right? I had him walk that way and then walk this way. So I had him walk, actually I guess I should say he walked this way and then this way. He walked X first and then Y. And that would be twice the length, right? But the player doesn't see that motion. The player doesn't see him walk in a stair step. The player just sees his final location because remember, we haven't drawn him in between here and here. Instead, we just added the two together. So the player's just going to see him at this final location, and in the player's mind, they are going to reconstruct the motion of the guy to have been this diagonal line, right? The player will never think about the fact that we actually moved him along X and then Y in terms of what we did to the variables that contain his location. They will instead just see the fact that he moved from here to here, and because they are human, they will assume that motion happened along the shortest path in between those two. Totally reasonable assumption. But that's where the phantom distance comes from. It would be twice as long if the player thought of it that way, but it's not. They think of it this way, and this is a shorter distance because he's going straight between the 2 points instead of taking that detour. So hopefully that makes some sense there. So we could ask ourselves, of course, if you remember your high school, I want to say it's geometry. I don't know if it's in trigonometry or geometry. I'm not sure when they teach this. I don't really remember. But if you wanted to know precisely how fast this was, right? I'm basically saying that I have some distance d, right, that he traveled, and he traveled d and d, right? He traveled d this way and d that way, and then we want to know this thing that the player observed, right? I don't know what we'll call this exactly. We'll call this m. I don't know why. We want to know if we wanted to know how long m was, right? We want to say what actually is the speed that the player ended up moving at, right? Who knows? Because we knew we moved him d this direction and d this direction. So if the player was thinking about it in a stair steps fashion, he would think he moved 2d, right? He would move d plus d. That's how far the player appears to have moved. But in this case, they see this line. So how big is that line, right? Well, this is that Pythagorean theorem that maybe you will have remembered from your grade school math. You notice there is a Pythagorean theorem. It's a thing that basically says if you have a triangle that looks like this, right, and it's a right triangle, let's say, so it looks like that.
I'm definitely going to be coming back to videos like this and also just my understanding of how to apply this stuff when it comes time to teach my own kids math, right? Because I remember learning a lot of this stuff, and I had just like an innate interest in math from a young age to the point where, and I think I've mentioned this before, where I was far enough ahead by like second grade or first grade that they started bumping me up to second grade. And I remember thinking that this is scary. I don't want to be good at math anymore, or at least I can't overperform in math to the point where it's like pulling me away from the friend groups that I'm establishing. And then I'm forced to hang around with these older, bigger kids that are scary and don't like me because I'm, jumping ahead in math. And they're like, who's this guy? I think he's all smart. But I remember having that innate interest in it that waned over time that would not have done so if I had been shown this application of math or any kind of application of math beyond just like here's Pythagorean, Pythagoras theorem or whatever it is, here's trig, here's calculus, here's differential equations, and these are all the types of things that he went over in the previous day, which is exactly why I thought that was going to be pretty dry even for me to sit through on stream. It's enough to sit through it on my own time, but we'll definitely get to write some code here soon.
Right. In a right triangle, I know that I can make sort of the Pythagorean theorem tells me that I can make an inequality about the lengths of the sides, right? And that is the a squared plus b squared equals c squared that everyone hopefully can remember. It's a very famous thing, right? This is the Pythagorean theorem right here. Well, that would give us exactly the answer we want, right? We have exactly that. Our only difference is that our a and b's actually happen to be the same. So we actually have an even weaker problem to solve here. So basically, if you think about it, we basically got d squared plus d squared equals m squared, right? Is essentially what we would need to solve. And so that's just 2d squared equals m squared, right? Or if we want to rearrange those terms, we need to basically solve for our m because that's what we want, and it's squared here. So if we want to know what it actually m is, we just have to square root this side, right? We just have to square root that and say, well, it's 2d squared, but square rooted, right? And what you'll see is that since this is already squared in here, right, what you will see is actually this, we can simplify it even further and just pull the things out and say, well, 2d squared, we can pull the d out of the square root by actually square rooting it and just say that it's d root 2, right? We can't really simplify that anymore because root 2 is not going to be a whole number. That's going to be, an actual long decimal. But that right there is the answer. And so what you can see is if you have a movement where you're moving by x and by y by a certain amount, which is d, then the actual movement when the player starts walking on the diagonal, the actual movement that they will appear to have is root 2 when they start walking on the diagonal, right? And so root 2, if we actually do that, we jump over here for Emacs fans and do quick cal. I don't know if it can do this. I want to see square root of 2. It can't. 1.4, right, is roughly where it's at. So basically, they're moving at 1.4, roughly 1.4x the speed that they should be moving at when they're going in that direction, right? So there you go. Very, very simple. Really basic math. Like I said, it's something that you would have learned in high school, but it's that's game development. Even very, very basic math is important. So that's how fast our guy's going. Now, what we would like to do is say that, for example, he always goes D. So if he goes this way, he goes D. If he goes that way, he goes D. And if he goes on the diagonal, he still goes D. So we're going to basically say we want it to kind of be on a circle, and we want to kind of make it so that we truncate off, we get rid of this extra that we were adding there. We want to make that vector actually be length D. So here's a question for you. Without doing any vector stuff, without doing anything yet, let's ask the question, what would we do? And you guys should all be able to answer this yourselves. If you want to just pause the stream for a second, if you want to go think about it, because you might take a little while. But what would you do, again, just using high school math, nothing fancy here, don't even need to use the term vector. What would we do if we actually wanted to figure out how far to move the guy when he was on the diagonal? So we're actually just if we were just going to straight up put an if statement in our code and say if the guy's moving on a diagonal, we will reduce D. So instead of moving him by D player X, D player Y, we'll move him by like some portion of player X, player Y. We'll straight up multiply this in the case of diagonal. What would we multiply him by to make it be only D long, right? We want this to be D long. Now, I'll give people a second to pause the stream if they wish to, and then I'll go ahead and talk about that.
I feel like I'm obligated to pause him and try and answer it. I mean, you just add them, right? No? No, yes, no? Or is it, what is it, a dot product? I was doing this stuff every day for like months, and then you write the code that does the thing, and then you just call the thing, right? So I programmed away the need to understand it. So already I can't answer this off the cuff, but it's something like that, right?
All right, ready? There we go. Okay, so basically what we're talking about here is we have a situation, right, where we've got D here, we've got D here. That's what we've been doing. And now we want to construct another D, right? We want to construct a D, but we want to construct it, well, that's an awful circle. We want to construct it so essentially we have another D right here, right? So we want to be able to construct a diagonal, an X and a Y that will give us, after they move the stair-step pattern, right, will actually give us a total length of D instead of each side of the triangle being D. Because before what we had, right, is we had each side of the triangle being D, and that's what led, that this was D and this was D, and that's what led us to the problem. And so basically what we want to do is say, okay, for this tiny triangle here where D is actually here, what would we have to make these? Well, like I said, I already told you the answer, actually. I just didn't want to give away too much of a hint, right? But I already said a squared plus b squared equals c squared, Pythagorean theorem, right? So we know that we have a triangle again. We know that we have our triangle here again, right? We're saying that we want this to be D, and now I'm asking you, what would I put here and here? Well, we know we want to move on the diagonal exactly, so we know that they're going to be the same value, right? And so whatever this value is, I'll call it V, I guess. I don't know, unless you want something else. I can just use the Pythagorean theorem again, just in the other direction. Before I used it to figure out what D was from the two sides, but I could just do the reverse, right? I can just say, well, now V squared plus V squared equals C squared, right? Again, because this is my A, this is my B, and this is my C, right? Oh,
It goes back to what he was saying. Like, we just have the same length going in X and Y for both of those vectors, right? So, hold up. I don't have a whiteboard, so I can't actually draw this out, right? But he's going to take the square root of both sides so that we just get D on one side. And so we have basically a squared plus b squared, or v squared plus v squared. Take the square root of that, gives us D.
Sorry, D squared, right? Just copying those, cut and pasting in the equation, right? Copy pasta works in math just like it does in code, right? So basically I just got 2v squared equals d squared, or v squared equals d squared over 2, right? Or v equals root d squared over 2, right? And that's all. That's it. That's all we're really talking about. That's the entirety of the thing. And again, I'm really bad at math. I say this all the time, but I mean it. I make mistakes in these sorts of things a lot, so I'll just go ahead.
Well, I guess I calculated for the wrong side. I got D instead of V. But right, if you were to square both of these now and then multiply by the 2, then you'd have what is that? Yeah, square both sides, then you get V squared. Multiply, well, no, I can't. Yeah, and then you have to take the square root. No. Yes, yeah. So you'd have 2v squared. Square root of 2v squared equals D. Something like that.
And even reinforce that by saying, let's plug it back in and make sure I didn't make a careless error in copying the terms, because like I said, I will, if you don't see me make one on the stream, I will be shocked. I will make them often. And so anyway, if I have d squared over 2 squared, I'm just taking this equation, plus d squared over 2 squared. That should equal d squared, right? So squaring this guy, it just removes the square root. So I have d squared over 2 plus d squared over 2 equals d squared, right? And then I can multiply everyone by 2, I think here. Is that correct? Well,
Okay, I see. Plugging in d squared, the square root of d squared over 2 for each of those v's, and then calculating it from there.
oh no, these guys add together, right? So then I have basically 2d squared over 2 equals d squared, and then I multiply that out, and that.
I was never good at the part, at the language part of like articulating what math is doing. Like I could always work through it in my head, but I never developed that skill, like to be called on and then be able to explain. Like I'd be able to do it if I'd spent enough time doing it in my head to where you could build that intuition. It's like, what are you even asking me? Something about mixing letters and numbers together. Your brain has a hard time developing an intuition for that unless you're just like inherently math brain, right? Which it's weird for me because sometimes I feel like I am, but then I'm watching him explain this, and for whatever reason, I can't just like off the cuff intuit what it is he's doing, other than, we know we're trying to get D, right? That's what we're trying to get to.
That's right. I mean, you can cross out the 2's, cross out the squareds, d equals d, and that's yeah. So that seems right to me. Let's assume that's
so
good enough math checking.
He plugs it back in to be able to basically prove that this formula for what v is, plugging that in for the original equation gives him d back. Okay, so it's like the proof. I'm not one of those people that was ever super, and this is why I think the application side is much more interesting. The application of math. I was never that person that, as interesting as math was for its own sake, I could never be that guy that's just gets very excited about proofs. Not that they aren't cool to watch, be done, but it's always more fun to actually apply it for me.
For now. But those of you who are good at math on the stream, you'll have to basically take notes, since I don't want to cheat and look at the stream, take notes on everything I do here, and you're welcome to basically post at the end, maybe on the forums, like here's corrections where Casey made a mistake. That would be probably pretty helpful for people trying to learn. So anyway, if we wanted to implement something where we moved the right speed, we now know what we would do. We would use d squared over 2 square rooted, basically. And that actually, again, can be simplified further if we wanted to, because that square root, we could pull out, we could basically treat that as a 1/2 d squared, right? That's what that is, which means we can pull out the d again, just like we did. So it's basically just d square root of 1/2, right? So all that means is, since we're already doing the d, quote unquote, right? This is our d in this case. This is the amount we wanted to move by. In the case that he was moving diagonally, all we really have to do is figure out what's this square root of 1/2, right? So what's the square root of 0.5, right? That's all we actually need to know. Can we paste that in there? Yeah. Basically, that's all we need to do is multiply our value by this. In the case where he's moving diagonal, we just say, okay, if he's moving diagonal, we just multiply our values by that value, right?
Like he's really teasing it apart and going as incrementally as he possibly can to get from, no pun intended, I guess, point A to point B. But why not? We'll stick with the way he's doing it, because that's only going to be better for me. I can understand, I can appreciate better why vector math becomes so valuable in games programming this way, and any sort of like graphical related programming. It's so heavily dependent on this sort of thing. Do I want to just write in like the first 4 there? It's probably what I want to do. Yeah, 7071. And actually I'll clear these on the same line just because I can. I'm sure this is a crime against mathematics, not using more significant figures, but so be it. Oh, I see. We don't need to declare them. Devil said, all I remember from discrete mathematics is pigeonhole technique. See, I don't even remember that. In fact, discrete math, I hated, and it wasn't because like I thought discrete math was hard or anything really like that. It was the circumstances under which I took that class, and also just the nature of that class. I think I actually swapped that class out within the first week. It was so bad, and I took something else that applied. And it was also because like that was the one class that I had not taken. I think I switched that out for like a programming languages class where I wound up having to write Perl for 10 weeks. And so I was screwed either way. But yeah, that discrete math class was so painful. The way it was being done, it was very unclear to me what the rubric was, and like the requirements for passing the class were so shaky that I just within the first 2 weeks I swapped that out, and I was not just not happy about it. It was like the very last math related class that I would ever have taken, and it was years after I had done my Calc 1, 2, and vector calculus classes. And so I was at that point like deep in like all kinds of more high level programming stuff, and then here I have to go and look at discrete math. It was a non-starter for me.
There we go. So we'll say if d player x and d player y, right? Or maybe I'll be a little more explicit here. If they're not equal to 0, so if both of them are set, then we'll do that. And that would actually, I believe, if we've done the math correctly, that will correct that motion. And now you can kind of see how, I believe,
not equal 0 and d player y does not equal 0. Then we just set that so that we're not going extra fast along the diagonal anymore. And I did something wrong for sure. It's because I didn't times it. Yeah. Can I actually do that in a one line? Yeah, I can't even do that on one line, so I played myself. I have to do this in 2 lines. Or if there is a way to do it in 1 line in Odin, I just don't know what that way is, so. Whoops. Yeah, that makes a whole lot more sense, doesn't it? Yeah, so when we were going diagonally, we were set to that much smaller D player X and Y. But now we're good, and that sure looks to be the same speed, diagonal and left to right and up and down to me.
If we've done the math correctly, that will correct that motion. And now you can kind of see how he basically goes at a much slower rate than he was going before when he moves downward. There we go. So now, of course, I can't actually say whether it's exactly correct or not because, well, it's kind of hard to eyeball these things, to be honest with you. I think he is. Don't know. It's hard to say. Maybe he is. I wish there was some way I could easily tell, but I don't really know. Yeah, hard to say, but there you go. I'll double check the stream. Yeah, it looks like none of the math people are like, oh my god, what did he do? So I think that's a good sign. All right, so anyway, now that we've got that straightened out, we can get back to sort of the topic at hand, although that all kind of was leading up to the topic at hand, which is, again, if you look at this, if you keep looking at this, we're constantly talking about these two variables together, and so again, that kind of motivates us to start thinking about them a little more cleanly. So basically what we'd like to do with vectors is we'd like to start having ways of not having to do all of this work all the time, just to do basic operations like make sure that something is the right length, right? Ideally what we'd like to do is be able to say, let's create a system of tools that allow us to quickly do this so we don't have to be writing math all the time. We can just have basically a series of operations we can conceptualize that are things like make this be this long, or make this be perpendicular to that, you know, those sorts of things. We want to be able to start thinking about them in those ways, and that is a lot of what vectors also give us, is that sort of mental, conceptual and semantic sort of simplification, so that when we're working on game code, we don't have to think at this low level, right? We can think at a higher level, kind of like C helps us go a little faster than assembly, right? Basically, going up to vectors helps us be faster than what's called scalar. Scalar is when you're doing it as single values instead of being combined. All right, so let's talk about those. Let's talk about vectors a little bit. So basically, like as I've already alluded to, vectors are very much just about putting together multiple pieces of information that are coupled in some way because you want to operate on them and work on them together. And so you've already kind of seen me draw the diagram because we just started talking about it, even though I wasn't saying vector specifically. We actually already just did draw one. If I have something like that vector for the diagonal motion, where basically you can think about a stair step, right? A stair step, that stair step pattern, that right angle stepping pattern. that basically is an X movement followed by a Y movement that gets to me to my final location. Well, basically what vectors are doing is they're letting us start to think about this part instead. So instead of thinking about things in terms of this stair step, we can now just start thinking of them as the direct motion from the origin directly to whatever the final destination is, right? And that works the same pretty much no matter how many dimensions you want to have in terms of if we're just talking about basic Euclidean, basic Cartesian coordinates or whatever, you know, as long as things are relatively simple and we're not talking about on the surface of a sphere or on the surface of a Klein bottle or God knows what else might be happening in real math world. If we're just kind of talking about this at a basic level, this actually works pretty cleanly no matter how many dimensions you have. So, you know, if we wanted to start talking about three-dimensional stuff as well, the principle is pretty much exactly the same. Nothing really changes. You just have a third axis and your third stair-step pattern. So instead of me just going along X and then up along Y and calling that the point, right, I also now move out along Z some distance and get a diagonal point that goes from the origin out to wherever that is, right? So it's basically like a 1, 2, 3 kind of a thing, right? Where there's two right-angle stair steps that happen, and then I finally get out to a vector. But at the end of the day, the concept is still exactly the same. It's just a motion along X, motion along Y, motion along Z. And so no matter how long our vector gets, right, no matter how many elements we have, A, B, C, D, E, F, G, right, you know, so maybe we have vectors that are X, Y, Z vectors, and that's what we're used to dealing with in games, but we can have them as long as we want, and we can conceptualize those as multi-dimensional things, even that go up to 4, 5, 6, 7, 8, however many dimensions we want, that are all just about that same process, right? And again, there's lots of other ways to conceptualize vectors. They don't have to be about these sort of right-angle coordinate systems that I'm talking about. They can be a lot of other things too, depending on what you need them to do. But this is really what we care about for our purposes, is vectors that are constructed at these right angle, or it's called orthogonal when you basically have these coordinate systems that are nicely sort of right at right angles to each other, where X, Y, and Z are all at right angles to each other, and they make this nice stair-step pattern that you can conceptualize. Again, doesn't have to be the case for coordinate systems, but it's the kind that we typically deal with.
It makes me think of, like, when he uses the term orthogonal, I've always thought of that word, and like before I entered the professional world, a lot of terms in math vocabulary, I just attributed those things to math. But then you get into the corporate world, and a lot of people use all of these words to sound smart in a corporate setting. And it's like, why are you butchering the meaning of this word by attributing it, you know, applying it in these circumstances? Just shut up and say what you mean and leave the math to the math people. We keep on appropriating math culture, and it has to stop. It has to stop.
Because they have a lot of nice properties that make them easy to deal with. All right, so all we're really doing when we say vector, right, is we're talking about that combination. So in this case, we want to start talking about X combined with Y, and the typical way of writing it is like this, where with two vertical bars and then the things go vertically. To be completely honest with you, I don't really know the history of why vertical is more typically the way that like vectors and points in 3D space are written, as opposed to horizontal. Like this is also a vector, right? Basically, you could think of them as matrices, right? A matrix is basically you make two bars, right, and you start filling in entries into it. And it could be two-dimensional, or even more. It could be three-dimensional, whatever. And a vector is kind of like a matrix that only has a row or a column. Now, why you would pick rows or a column specifically, I mean, there's no real difference between the two. It just inverts kind of how you look at all your operations, as you'll see when we go forward. And so somebody at some point, and if you know math history, I'm sure you would probably know this, and like I said, I don't. Somebody picked this as the preferred method for talking about vectors in 3D space, and in fact, so this is what you would typically expect to see written, and when you see this, you're actually talking about a different type of vector, and we can talk about that a little bit more a little bit later. But basically, once you decide what your convention is for how you're going to write, if you write things vertically, then writing things horizontally actually means something different. And if you think about it, it makes some sense. Again, jumping ahead a little bit, but if you have, let's say I had a matrix, you know, a 2x2 array of numbers, let's say, this is a column of that matrix, but this would be a row of that matrix. And so you can kind of think of this as being like the column of a matrix, and this as being like a row of a matrix. And so when we actually talk about doing operations on these later, it matters whether you're talking about something that's like a column or like a row in terms of who affects who when they are operated on. And so that's why I say the notation is a little bit, it can be a little bit daunting, it can be a little bit tricky, it's true. But basically for right now, all you really need to know until we get a little bit further up is that the way that we want to write these for now to be consistent mostly with mathematics is that we're going to put them vertically like that. It's annoying in code because you can't make code vertical because editors are from 1970 and can't write a stupid vertical vector in the middle of your code for some reason, but that's where we are. All right, so basically what we're talking about again is starting to talk about this object, and we're going to write this object like this. Whatever its x step is, and whatever its y step is, we put the x in the top and the y in the bottom, and that's our vector, right? Everyone's happy. And then once we have that, we can start to define operations on this thing as an object. For example, let's suppose that we had two of these, right? So I'm going to call this x sub 2, well actually, let's make it x sub 1, this is the first one, x sub 1, and then I'm going to talk about another one here that's x sub 2, y sub 2.
This also does, maybe I have like a hearing or a speech problem or something, but it took me a long time to figure out that when people are notating like x sub 1 and x sub 2, like that sort of thing, like that sub notation, for the longest time, maybe it was like a language thing. Maybe it's because my dad has an accent and I never really understood like being around him, growing up around him, because he would actually teach me a lot of math, now that I think about it, when I was really, really young, before I started getting into the higher level stuff. Like in high school and just in general, he stopped teaching me because I'm guessing the math got more sophisticated than what he could just remember offhand. But when people would start doing that x sub 1, y sub 1 stuff, like my teachers in school, I would think they're saying x of 1 and y of 1. And I'd be like, what the hell are you saying? And then that gets me off track of like where I'm actually trying to be, like in the flow of like, what are we doing? Devil said, can't you just orthogonalize the program to meet our requirements? Yeah, like if you just say the word, if you just say operationalize enough times, then you'll, just by virtue of the fact that you sound smart when you say that word, the outcome that you want will happen. That's how that works, right?
Right? So here's my x sub 1, here's my x sub 1 there. And let's say I have another vector, right, that's like this. Actually, let me make it a little bit wackier. Let's say that it's pointing like almost straight up. So it's like this, right? And so here's my here's my x sub 2, right? It kind of goes over that way. And here's my y sub 2, which is almost as close to, it's a little bit less than that one, right? Well, again, like I said, we're just talking about the object here, but the point that's very useful to sort of emphasize at this point is even once we sort of talked about these as being composite like this, we can already start to do some interesting operations with them. For example, right, we can add two vectors together, and basically that just does exactly what you would expect. It puts one vector at the tip of another vector and finds the resulting point, right? It would basically move this guy and would say, what if he was at the end of x sub 1, right? So I'm going to start at x sub 1, y sub 1, and I'm going to move by this amount, right, which is this vector here. So my new point is here, and the resulting vector, right, which I'll call x sub 3, y sub 3, right? The resulting vector is this vector right here, right? Now, you know this intuitively because we already have done this in the code to some degree. We've already done x's plus x's equals x's, y's plus y's equals y's, right? That's how we were moving our guy. So we already expect this to be true. We already expect to be able to take some point in 3D space and add some other point, basically, and have them be arrayed tip to tip like that. Now, it's worth noting that sometimes there's a distinction between points and vectors, and we can kind of get into that a little bit later. But for now, we can kind of think of vectors as defining either a point or like a delta, right? So we could think of this as being a point and this as being like a delta, and we're applying the delta to the point, right? But really, they're both the same type of object as far as we're concerned, and they can be interchangeable. That's not strictly true in all mathematics, and depending on how you want to talk about these things formally, you may actually have a difference between points and vectors, for example, that make them behave differently. But we're not really going to look at that right now. That's kind of a little bit past what we're trying to do at the moment. But it's worth mentioning. So we basically got a single type of object that we're using to represent both of these. All right. So again, the same would be true for subtraction. Basically, what subtraction would do is it says, what if I go in the opposite direction, right? So if I'm subtracting x sub 2, y sub 2, right, from somebody, then all I'm doing is I'm taking this vector, I'm flipping it, right? I'm flipping both its directions around, and then I'm going to put it at the end and move here. So that result would be somewhere down here, right? Make sense? Again, very, very straightforward. So addition and subtraction, very, very simple. They make a lot of sense. Now, the other thing that's easy to understand and makes a lot of sense is scalar multiplication. If I had some amount of times I wanted to move, like let's say I've got this vector here and I want to go 2 or 3 times its length. So however far I would go from the origin of my coordinate system, which is that base at that 0, 0 point, how far would I go if I did 3 times this motion? Well, I'd just go once. I'd put the same vector on the end of itself and go again, right, and again, right? So scalar multiplication, if I wanted to say like 2 times x sub 1, y sub 1, scalar multiplication is basically just adding the vector to itself, just like you would do, just like 2 times some number is just saying that number plus itself, you know, twice, right? The same is true here. 2 times something is saying exactly the same thing. It's saying I just want to add, right? So all of those things are should hopefully be pretty intuitive to you, should make a lot of sense, because basically they're just things you would have done with the scalars already, and all we're talking about doing is bundling them together so that we can type and think about things more easily, because we can start to think about points in 3-dimensional space more easily. Now, what's going to be a little more confusing, however, is when we start to talk about multiplication, because multiplication actually in vector space gets a lot trickier. So let's talk about that briefly, and then maybe we're gonna go implement the basic things, because we've only got about 20 minutes left, so I'm not really going to do much multiplication today. But let's go and think about let's go and think about that multiplication now. So all right, so here's my coordinate system again. Again, this is the origin of our coordinate system with the 0, 0, let's say. This is our x-axis, our y-axis. Here is one of our vectors, okay? And then I have some other vector up here. All right. And now I want to multiply these two together. And so I'm going to start actually talking about these. Again, I'll put them right here. I'll say this is x sub 1, y sub 1, and this is x sub 2, y sub 2. Again, just like we did before. Now, if I want to multiply these two vectors together, you might say, well, why don't you just do the exact same thing you did before with addition? Just if I want to have x sub 1, y sub 1 times, which we don't actually know what that actually is yet, I'm just going to write it, x sub 2, y sub 2, then Casey, why don't you just do exactly what you did before and just do it as if you were doing it to each component? Because remember, when I did addition, right, that's all I did. I basically didn't do anything fancy. I didn't seem to invoke any real math fanciness there. I just did to the components what I would have done if they were scalar. I just did, okay, you want to add? Then add the x's, add the y's, and put the results in the x and the y slot, right? That's it. And I did the exact same thing with subtraction. Change that to a minus, you just change these to a minus, right? So why not do the same thing with multiplication, right? If this were times, right, you know, in there, why wouldn't I just stick a times in there? Well, the answer is because it doesn't really do anything that you want it to do. So this does have a name. If I'm not mistaken, this is called the Handmade product. It does have a name, and it is a valid vector operation.
I call it the hard product for short.
It's defined. It's something you could do. But what you will find if you actually try to program with this is that it's really only useful for colors. And it's basically something that you end up doing to, like, you know, you've got some gray level and you want to multiply it by a color to get out the color thing, or, you know, you got some kind of, it's really, you're not going to see a lot of use of it in code for actually doing positioning and movement things, which is what we're trying to do. And the reason why that is the case is because the actual operation that this implies doesn't really make any spatial sense. If you look at what's going to happen, we're going to take however far we are along one of these, right, axes, like so take x, we're going to take however long the other one is, and we're going to multiply those together to get some multiplied thing here, right? And then similarly, we're going to do the same thing on this one to get some multiplied thing here, and we're going to get a result that's like out there, right? Now, this result here isn't, if you actually go and apply, I should say that for 1 second. Let's say that till the next thing we talk about. But basically, this actual result, when you do these things, doesn't have really any properties that we would care about. It's not something that's the two lengths of the vectors times each other, really. It's not something, it doesn't really give us anything that we would ever actually do in practice, right? And you'll notice that we've never done this anywhere in the actual code either. Like, it's just not something that happens very frequently. So typically the only time, again, that you see it is something with like colors, or something where you have like, where you've just packed things in some way, like this, you have an X rate and a Y rate that you want things to happen at, and you've packed them in, I don't know, weird stuff. It's just not that common, right? The other time you might see it is like some kind of a knockout filter, like you've got something where you've got like a mask kind of a thing, where like, oh, I just want to knock out the Y component, so I'm multiplying by this thing, or, you know, there's weird circumstances you will see this sort of thing happen. Certainly I don't want to say that it's never used, but it's just not that common. And the reason is because, unlike these other things like addition and subtraction, had very obvious things that we would want to do that made sense, like moving along one and then moving along the other, or those sorts of things are very common operations we'd want to do positionally. So the Handmade product is not really something that we want to focus on, although we could implement it. What we're actually going to do eventually is we're going to use the dot and perp dot products, right? Which are other types of ways of multiplying vectors together. This would actually be more like a cross product in 3 dimensions. And these are terms which you don't know.
That's what I was trying to remember, the cross product. You got the dot product, you got the cross product, you got the hard product. So many products to consume.
Oh yeah, if you don't know vector math. If you do know vector math, you probably tuned out already because this stuff is very basic for you. But basically, we will be talking about other kinds of multiplication of vectors because one of the things that's very interesting about matrix, about linear algebra in general, and about matrix math is that because you have lots of values, you can start to define ways in which they interact that are more complex.
God, it's everywhere. It's everywhere. I've been thinking about it as he's been going over this stuff, like this math language that we use everywhere to try and make ourselves seem smart. Why don't we just operationalize in parallel so that the outputs, the products of our work can be concurrent, so on and so forth. We got a good result, and now we're rich, right? That's exactly how that works.
Than just going straight across, and it turns out that those different methods that you use can get you some very powerful tools. But we're going to have to save that for Tuesday. Sorry, not Tuesday, for Wednesday. So come back tomorrow if you want to talk about those products, and that's when we'll be doing them. For now, what I want to do is just do the basic work of replacing the scalar code we've got at the moment with some vector code, right? That's all I really wanted to do. Just very, very simple. So what I'm going to do is I'm going to make, I guess, maybe a handmade math.h. I'm just going to stick it in here because I basically just want some place to start dumping our math code. And I'm going to make a structure that is going to be one of these things that we just sort of talked about, the thing that I just walked all the way through. I just want to make something like that, and I want to go ahead and replace our code that we were using before with that, right? And this is the place where we'll finally use a C++ feature that's a non-trivial C++ feature, like I've said on the stream multiple times. I'm like, we're going to use operator overloading. We're going to use operator overloading. We'll probably use it here. I find that vectors are one of the few things where I really like operator overloading. In most places I find it's just not that useful, but in vectors it's kind of nice because you can get code to look a little more like math, even though it still doesn't quite get you all the way there. So really all I want to do is encapsulate exactly the stuff that we have been doing before. I just want to say essentially that we do have an x and a y, right? And I would like that ideally to be accessible in both ways. So I want to basically say that I have an x and a y, so if I want to type .x or .y to access the x or y component, I can do that. And then I also want to be able to say, okay, I've got an element here, an e, which is going to have 2 components so that I can access it procedurally and use a 0 or 1 index to index into the element if I want to, only if I want to, though. So that's going to be my vector structure.
Now, I don't know how Odin actually does this underneath the hood, but it's probably worth pointing out because I would not have been able to see why this could be valuable until I saw Casey having to do this stuff by hand, right? He creates the struct that holds a union to say this data exists in the same spot, the x and y, and then the array of X and Y. So we can access these things in different ways and also assign to them. And I had to do some really messed up stuff in Zig, and it may or may not be worth showing off a little bit of that. And actually, this just emulates code that I found. I don't know why ZLS decided to stop working. That's really obnoxious, but it was fine. I didn't touch it, and then all of a sudden, my Zig Leg-Winch server broke. So in here, I have these this vec class, or well, it's a function that returns a type, right? That's what this is saying here. So it's a vec function that takes the value of the number of dimensions that you want the vector to have, and then also the type that is going to be stored in the vector, and then it gives you that type back, and then it does a whole bunch of stuff here. I have all these functions that kind of match on the number of dimensions up to 4, and then after 4, if you try to call any of these, like for instance, if I want to get RGB out of this vector, or XYZ, whatever the context it is that we're dealing with. And then I also have all these setters too. So I have all these getters and setters, and this was something that I implemented partially by hand. I took a bunch of stuff out of this other code base's math class or something like that, or math module, I guess you might call it, the mock engine in Zig, and I did the same thing. I also added my own stuff to it, and I did handled a few other things differently. Like I think this is actually just a vector in Mock's code base, but anyway, like doing all this by hand made me appreciate, because I had to do it that way. You couldn't make a union the way that Casey does here, where you can just access that data in the same place using different means, and based on their type. But another way that I do something similar to that I can do in Odin is using the using keyword, which gives me all of my button states, in the same chunk of memory. And so I have the array of buttons that I can access if I need to, and there's 12 buttons. It's a maximum number we're allowed to have. And then I can also access each individual button in the array using the using keyword. And I have to do it twice. One, to be able to say I want this union inside of my controller input, and then again inside of that union to be able to say, okay, inside of this memory here is where all of my button state is, and then here's the different ways that I can refer to that. And it wound up being pretty much exactly how Casey did it. Why can't I, input, move, no. Why can't I find this code? Would it be, ugh. Am I really not, well I guess action up. I know we're doing something with action up. Oh, I called it controller, that's why. I was looking for something called input. So off the controller, I can look at my action up button, which is the up arrow on the keyboard, and then I can ask if it's ended down. And if I look inside of the Zig code, okay, ZLS, I get it. If we go look for like move up, look how much more work that is. I have 2 more accessors that I have to do. One for, like, I'm getting at the buttons, and then, which, am I getting at the map of buttons, or am I getting at the array? And so that's, well, once I realized that I could do it more in Odin, that kind of, there's something about that made me feel like Odin was more C-like than Zig, perhaps, at least as far as this goes. But that's just kind of a thing that's neither here nor there. And somehow I was on Casey's code that whole time. This is what I was trying to show. accessing an Odin just looks like this. It pretty much exactly how Casey has it implemented, right? Where I have this union, and then inside of the union there's a struct, and then in Zig I have to do it like this. And if I go, well, I can't actually go to the definition of this thing because CLS is broken. And I guess it's in my platform code. Game button state. What does that look like? Yeah, I actually had to break it all out, and I had to add this extern qualifier there. Not sure what else to call it. But anyway, it wound up being much more C-like doing it in Odin. And I don't know if that's, you know, how the Odin arrays work necessarily underneath the hood or not, but I suppose it must be something along those lines. I don't know. I shouldn't try and speak to it because I have no idea. Someday I'll bother to look inside of the Odin code base. But the point is I don't even have to define it that way because I can just do this and I get all of that for free, which is awesome. But Casey's going to have to do some work here to get to that point.
Really all I wanted to do there, and then I'm going to define those operations on it that I wanted, right? I would like to be able to define an operator to do that plus that we saw happen, right? So I want to take an A and a B, and I want to be able to add those two together. So I want to be able to basically say, okay, I've got a result, and the result is going to be equal to, you know, again, exactly the thing. Where's my pen? Exactly. And then I also want to be able to say, okay, I've got an element
okay,
here,
YouTube.
B, which is going to have two components so that I can access it procedurally and you know, use a 0 or 1 index to index into the element if I want to, only if I want to, though. So that's going to be my vector structure. That's really all I wanted to do there. And then I'm going to define those operations on it that I wanted, right? I would like to be able to define an operator to do that plus that we saw happen, right? So I want to take an A and a B, and I want to be able to add those two together. So I want to be able to basically say, okay, I've got a result, and the result is going to be equal to, you know, again, exactly the thing. Where's my pen? Exactly the thing that we did right here, right? I just want to basically say, add the x's, add the y's, and subtract the x's, subtract the y's, right? So let's see here. Here we go. So I want to be able to do, you know, that sort of thing. I want to be able to subtract. Again, this is really, really simple. You know, I want to be able to subtract. I'd like to be able to do a unary minus, if that makes sense. I'd like to be able to just say that a vector equals its negative, which is that flipping operation, like I said before, just flipping a vector around, so negating both of them. And I believe in C, it's been so long since I hardly ever program anything in C. But I believe you can do, oh, you know what? I think, can you still do that outside? I don't know if you can do that outside. Let's find out. Can I do that outside to something, or does it have to be in the class? You know, can result equal negative A? I'm just curious. Let's find out. I for some reason, I got that twinge in my head that was like, you got to put that inside the class, but I don't actually know if that's true. So let's find out. Handmade math.h, and that probably actually, handmade.h. That's probably something that we're going to want to use everywhere, I assume. We'll see. Certainly, at least not here. Okay. Oops. Oh, yeah, sorry. Didn't quite finish typing that in there. That was wishful thinking. Okay, so I can do that outside, so that's good. All right, so basically I've got the ability to, you know, be able to say, you know, B equals negative A. That's what that guy does. I can say A plus B, and I can say A minus B, like that. So that's all good. And then I also probably want, like I said, the ability to multiply by a scalar. So I want to be able to say something like, you know, I've got an A and a float of some kind, right? So I guess it'd be something like this, if that makes sense. So then I've got a result, and I do result dot x equals b dot x times that A. There we go. And return result. And so you can just kind of see that all I'm really doing is just making some really, really basic vector math routines that are doing exactly those things that I just went over on the sort of, I don't know, on the Krita whiteboard, if you will. So now if I want to actually start putting that into code, I can just look for the places where previously I was doing those sort of x and y operations, right? And I can start to actually, you know, make them a little more concise. So what I can do is I can look through here. I'm just kind of randomly sampling through the code and thinking, all right, I've basically got, you know, this player x, player y thing here, right? I could turn that. Certainly that's the one we were looking at before. I can basically say that I've got one of those that's going to be cleared at the start. And then if I just compile it, all I have to really do is now go every place that I was doing something to one of the components. I can just kind of do it to the scalar.
All right, so I can go ahead and follow his lead there. So if we go up to dplayer x and y, and I tried, I had to explicitly say that these were F32s. So I couldn't just be, well, I mean, I could have just done this, couldn't I? And that would have accomplished the same thing. Yeah. So over here, we just say we have a delta player, and it's a V2, right? And then get rid of those and try and build. And I think we can just start working our way down through here. OLS will be kind and tell me all the places where we need to fix things that are broken. You can see I didn't have to do any of this, and I don't know why, but that is just so cool to me that I don't have to do that kind of boilerplate. Here's what a vector class or type, struct, whatever is going to look like. I just get these fields and I can assign, and in Zig I'll just keep going back and forth here because this is like the thing that I've been looking forward to getting to for a long time. Like if I look for some kind of like actually this is going to be here, this is going to be in man, I'm just messing everything up. What? Oh my gosh, no, quit changing code. If I go and look for a place where I'm accessing yeah, here we go. So I have to actually call to get at my X field on my vector, you know, in this screen bounds variable. I have to actually call it like a method. It's not a field. It's not a member that I can just access. And if I go in here, yeah, the ZLS is all jacked up, so that's not working. But you get the idea. And then in some other places, I'm having to access the field and assign it like off of the vector instead. So I can't do, like, it's either I have to implement it like this, or I have to, and because I can't just do, what is that? That's Z, I think, right? If it's the third element. So I can't just say, you know, Z equals this stuff, and I can't do this because that just gives me the value. So if I wanted it to be a method on the thing, I'd have to like do set Z or something like that. And that just got really old after a while, and I thought that I would get used to it and it would quit bothering me, but it never did. And so here I am learning Odin after spending all that time learning Zig. And that's not really a condemnation of Zig per se. It's just that because there's ways around it using Zig's vector type. Like if I look for if I look in the math module here, like I do have, Vector does have this built-in vector type, but it just doesn't, it's not as flexible. And especially once you start getting into alignment issues, which I could run into with Odin, but I'm not going to worry about that until I get there because I won't know what that'll look like until I actually have that problem. But I think we'll be okay. So I think this might just work now. Yeah. So nothing changed. Had to basically add no new code. There's like 3 new lines of code to, well, it wasn't, they weren't even new lines of code. I just moved those type declarations over into the math file, and we're off.
Any place that I was doing something to both, I can just make it operate on all of them. And I can go add that star equals as well. Looks like that would be something that would be useful, right? So I can do that, certainly. That'd be easy to add. And then here I've got this guy. And again, this is like now a double add. There we go. And you can see that the code almost doesn't change at all. Really all
that's right. So where was that? D player dot x times equals. So if we did, yeah, okay. So I actually don't know for certain that this will work, but I think it will. OLS is complaining, so I think we're good. So I can also just multiply the vector by a scalar, and there's just something about being able to write code like this in Odin that makes me feel like how I felt originally writing Ruby way back when, and Ruby was just so expressive in this way that lets you just articulate exactly what it was you wanted your code to do. But to be able to do that in a lower level language like this is just kind of, there's something really exciting about that feeling to me. And I can't quite put my finger on it other than to say that it's really, really cool.
Happening is if I start to get rid of these, I start to basically just get 1 line of code in a lot of places that I used to have 2, and that's really, you know, that's really almost the entirety in the entirety of it. So let's take a look. I need that times equals because I'm using that, and I also need to go.
So he's just starting to do that everywhere. Here, It looks like he was changing the player's offset X and Y. And for some reason, I can't go to definition for these. So would that be like tile map position? Yeah, offset X and Y. So if we just say that this is the offset and it is a vector 2, and then we do that, we're going to have a whole bunch of things get busted. So let's go back into game main. Was that line 697 over here? And this here, actually, we want to just access the fields themselves. Let's see where else we got to make changes. 617. And this is actually, well, where was he changing that? He was changing that in one line here. So instead of, well, let's yank that and then comment that out real quick. And now I can just add to the player's offset. It also makes it, when I get to just do this and start adding to vectors like this, so here's another thing. If I want to add a vector, like I'm going to do here, we're going to scale the player's delta with the DT for frame, and then we're going to add that to the player's offset vector. To do that stuff in Zig, I was having to, let's see, where would it be, like in render, where I'd have, yeah, I think if we went down into like draw rectangle slowly, or maybe quickly, yeah, if we went down here, I'm to add vectors, I can't just add my origin and my x-axis. I have to call add off of the vec2, type that I've defined, and then I have to pass in the reference to these things, and that it doesn't have to be a reference. That's just the way that I have this set up. But the other way to call that would be, like, I'm not happy with either of these implementations, whether I have to call add on the type, or if I wanted to call origin.add x-axis. Neither of these feel as good as just saying plus equals. It's just, maybe that's just a thing that people like me are going to get fixated on, and plenty of people wouldn't care about having to do stuff like this, but that got really old after a while. So I don't know, just it feels cool to finally get to this point where I can start making these changes to use that power of Odin, and also just it makes me appreciate it that much more. Here, actually, could I do this? Could I assign the player's offset, the initial offset, with just like one assignment to 5? So this will set the X and Y fields on the offset to 5, is what this seems to be indicating me, because I'm not getting an error. So that's pretty neat. And then we have a bunch of stuff to change in tile. And this, okay, so we're adding, yeah, well, I don't think we can do this in one line, actually, because we have dtile X and Y, but maybe he'll combine that into its own vector. And then you could, right? Maybe I should wait for him to get to that point. For now, we'll just sub out these individual member axes out for getting them off of the offset vector. Getting closer. 202. Now these are just going to have to be looking like that for now. And we're off. That is pretty awesome. That feels good. More of this. More of that.
Make handmade tile.h, make that offset via v2 as well. So there we go. And now let's go ahead in here and start to look at it. again, I could just quickly port it by doing the dot. Oops, didn't mean to do that right there. And then here, this is actually kind of interesting. So this looks a lot to me like something where I could simplify. I mean, that's doing the exact same math there, right? That's just a minus b there. And d tile x, d tile y, I could just make this right here also be a vector too, right? So I could basically say that I have something like this, right? Oops. I could basically turn this into vector math as well. So there's that.
Okay, so that's what I was wondering about down here. Because I saw that there was this z, d-tile z, and I was like, oh, do I want to like mess with a vector 3 here? And actually, I'm already returning a three-dimensional vector. So that's, yeah, I see now. Right. Okay, well, he's just going to make d-tile x, or d-tile be, it would be d-tile xy, I think is probably what he's about to do. Something like that. And then, yeah, and then he just wraps these into that declaration, right? And then here is where we could say, I'm just gonna, well, yank one line, do the same thing I did before, comment that out. I'm never as comfortable. The one thing that I noticed Casey does a lot of is he'll just make changes to the code, like very brazenly. Whereas for a long time, I've conditioned myself to like yank the thing that I'm gonna make changes to, comment out the original code, because I'm constantly having to go back and look at that original code and be like, what the hell was I actually doing here before I started making changes? And I guess, you know, that's just a skill that he has that I doesn't, or at least I've never tried to cultivate it. It's just something that I learned to do early on, so I can refer back to what the original implementation does so that I know, like, okay, how exactly does this need to work, so I can actually map it to the new implementation. And it just, I'm not there yet. Maybe someday. Maybe I'll get more and more comfortable with that as time goes on. So then we just do this, and I think that might work. Well, we can't do it this way, but we can swizzle the results, and that is actually pretty sick. Well, not swizzle, we're not swizzling here, but we are just saying, okay, give me the XY fields off of this resulting vector 3. So Casey isn't even going to do this much, but I get to do it just because Odin lets me do it, and that's pretty sick. That's pretty sick. No kidding. I feel so powerful. Array programming is a lot of fun.
D-tile x, and now that's basically the d-tile xy, if you will, right? And so now d-tile xy plus a offset minus b offset actually can directly do the result dxy in the tile map difference. So basically there's now one of those, right? And you can start to see that maybe, okay, well, there's also a dz, I don't know, should we maybe, you know, we'll have to start thinking about extending this to 3D, right? But again, one thing at a time.
Yeah, and he calls it a tile map difference. This is probably going to mess with what I'm doing with the result of this, maybe, or maybe not. Where am I calling that subtract proc? So we get the diff out. Yeah, no, that doesn't matter because we're just going to get the x and y fields off of the difference. And then over here, yep, same thing. I think I can go ahead and nuke that. And then up here, where were we assigning that original offset x and y? Yeah, that can just go away. Like, it just implicitly, that's what it's doing. It's implicitly splatting 5 into that entire vector. That is sweet. Devil said, see, what I do is make the change without the backup comment. The change doesn't work, and I don't remember what it was before. It's really efficient. Yeah, well, I mean, that's exactly what I'd be doing if I didn't not do that. You know what I mean? Like, that's, I can't, it's a terrible feeling. I mean, obviously, you can look at the diff, right? But I don't want to have to get diff. Like, what the hell was this code doing before? Like, I can just look at my old commented out code and be like, ah, okay, I see what went wrong here. So yeah, let's see. Yeah, so I think that's fine. If I go back into tile here, we don't even need to worry about the fact that he's got what he was just doing. And he's going to do this eventually anyways, I think, where he's going to just make this result be a vector 3 or a v3. But now he's got that, yeah, he's just storing the x and y in one member, and then the delta z is in another. But something I just realized. Yeah, he calls it... Okay, so because the result is a tile map difference, and he calls dxy, he calls that member a dxy, but I think I could just leave this like so. In fact, yeah, no, that's right. And then he scales that, adds it to the result of the difference between those offsets, and the result is the difference. This is fine. This is good. Okay. Just wanted to double and triple check before I make a grave error.
I don't know. Should we maybe, we'll have to start thinking about extending this to 3D, right? But again, one thing at a time. So let's keep going here. Too many initializers. Why is it too many initializers? Oh, right. That's true. I have to think about how to get around that. Because I want to be able to initialize that. The union makes things a little bit grimbly there, doesn't it? Because I can't quite do the initialization the way I would want to. Because I think C++ in its infinitesimal wisdom doesn't let you just initialize the first thing in the union or something equally awesome like that. Well, that's no bother. I can fix that pretty easily. We can just basically say, oh, and also these also should presumably all be inlines. They're trivial operations that the compiler should just kind of throw in there. So yeah, so let me just clean this up a little bit here. There you go. So what I'll do is I'll just basically say, okay, fine. If that's the way you want it, Mr. Lousy Language, that's fine. We'll just say that basically we initialize them this way, and we will do it like that. Okay. So now I've got a way to make them, so I can basically say, all right, here you go. There's my v2. Which that kind of makes me grumpy. I have to think about it. I try to think if I fixed that kind of thing in my own code before. I feel like I did. But how did I do it? You know what I probably did? You know what? I think I probably do know what I did. Here's what I probably did. Because I think I have done this before. What I probably did was I probably did that, right? And then I probably did something like this. Like, this sort of thing. Or like operator brackets, one of these things, int index. And I probably did something like, don't try this at home, kids, right? That sort of thing. I probably did something like this. Just guessing. Not really entirely sure, but let's take a look. So I think what I probably did was something where I would go, okay,
like I would never even think to begin to try and understand how to do this. You could only do this after having spent some time figuring out how to do it and taking a long time to internalize, at least for me. So he's declaring... Okay, he's declaring a member that is an operator overload of the indexing operator, which takes the index as an argument, and then it returns a reference to... I don't know if that's actually a reference, but the address of X at that index. Well, is it referring to the member X on the v2 struct? See, I'm so glad I don't have to even think about that. And like, yeah, I'll say no more.
Take the address of X and then get.
But at the same time, the thing that I'm trying to constantly, and I was thinking about this when somebody was saying the other day on a stream, like, you don't need to worry about this. And he was messing with compiler stuff, like compiling on Windows versus Linux. He was messing with that sort of thing. And somebody in chat was saying, you don't really need to worry about this because, if you're using Odin or Zig, then, the target is just going to be implicit based on, what operating system you're even programming on. Because when you go to install the language there, the language is going to be able to kind of abstract that stuff away. But, if I think about this realistically, if my goal is to become somebody who can work as a graphics programmer in the industry, just for example, because it's kind of a loose goal of mine. It's a thing that I think would be nice if that could happen, if I could find like the right job that would be, or just to do like contract work, I guess, whatever that looks like. I don't know what that looks like, or if that's even where this winds up. But if that's like a loose goal of mine, I need to be able to, I need to have exposure to this stuff in C. And so that's what I think is nice about watching Casey do this, is because I get to see the C/C++ way of doing the thing, and then I can go ahead and use Odin. But the odds of me getting a job programming in Odin are slim to none, right? It's much more likely that I get a job working with C and C++, either or even both. But so it doesn't hurt to watch him do this stuff again and continue to build intuition for how to go about doing these things in C.
A particular
or C++.
Index off of it, right? So that basically you end up with a thing. Yeah, I'll talk about that in 1 second. But yeah, let's finish our port first, and then I'll talk about that. Because basically, I like to be able to initialize things with this syntax, where I can just do my standard bracket syntax. And so unions, unfortunately, don't let you do that. And so you kind of have to work around them a little bit. All right, so let's take a look here. Let me finish all of my porting this. So I've got to have that times equals, which we haven't done yet. So let's go ahead and make it times equals. Those, I believe, do have to be member functions, if I'm not very much mistaken. So basically, we do need a times equals, and the times equals is going to be by a scalar in this case. And so that will be, again, just, I guess we could just call one of these guys, probably. I don't actually know if that's true. Let's see here. I feel like it should be, oops, relatively straightforward to implement one of those. So there we go. So if I want to do, yeah, I feel like, can I not just do star this equals a, that sort of a thing? I feel like I should be able to do this. Oops, times a, return star this. Is there any reason I can't do that? Let's have at least one formal parameter of class type. Operator, oh, and it's got to be a member function, certainly. No operator found which takes a left-hand type of v2. That's correct. Sorry, had them in the wrong order. Let's see, there we go. And then plus equals is the same thing. So I also need to be able to make that plus equals happen.
Almost left myself on mute again. Well, I did leave myself on mute again. All I was starting to say here was that I'm looking at this declaration of this method that he's making here. Well, I guess that's just how you, well, I don't understand the reference that he's making, right, to the v2. It says, so he's saying inline, it's an inline method that returns a v2. Actually, it returns yeah, no, because he dereferences this. I see. So it's a pointer to a v2, which this method is for, right? Or no? Because he's dereferencing this when he assigns. I think it has to be a pointer because that's how the operator overloading works, right? Like it's times equals. Yeah, that's how it has to work because you're assigning to the thing that you're operating on. Okay, I think I get it.
As well. So there we go. And again, I'm not really doing anything particularly interesting here. That's why I'm not talking a whole heck of a lot, is just because this is just a bunch of Grimble work. There's really nothing particularly exciting about it. I'm just sort of going through and saying, okay, what are all the math operations I was currently using? And then let me go ahead and...
I disagree. It's a little bit exciting because I don't have to do that work, but also, contrarily, I need to understand how to do that work. It's a conundrum.
Implement them in the most straightforward way possible. And basically all I'm doing with these plus equals guys is I'm just calling the same code I just wrote, but C++ is too dumb to figure that out, that you could just use a plus to make a plus equals. I mean, how could you possibly ever imagine that could work? So anyway, you have to write it yourself. And basically all I did was say, hey, by the way, just call the plus operator on you, right? Which is all I really wanted to do. So anyway, let's see here. What did I forget? Oh, I forgot that address line there. There we go. And so again, just going through and finishing the port here. So we're gonna, this is an actual modification of just the X parameter, so that's actually okay. And again, this is going to be one of these guys. Let's see. And I guess that looks very similar as well. Let's see here. So although this one does look like it's actually because it has to flip the Y, we may want to write that in a slightly different way. But all of those could probably be collapsed down now too. Like you can take a look at that right there, like the min x, min y, those are getting handled almost identically. Those could all just actually be vector 2s. So we've got it's kind of a rich, it's a fertile ground here at the moment for things. But I'm just going to go ahead and finish porting them that way just to make sure that we're still running okay. There we are. Everyone's happy. It looks like we're still working properly. No big problems. So that's all good. Okay. And then just taking a look now at the stuff that we could do here. Again, min x, min y is kind of looks like, and same with sen x, sen y. So basically, if I take a look at that sen x, sen y stuff, basically this looks like a big old v2 to me as well, right? This is something where I'm computing two values, and then I'm about to use them as if they were...
Go ahead and do the same thing there. Back into main we go, and what was that, sen? Called it sen, but I might be calling that center. Or no, yeah, over here. So center is a v2. And what do we have here? We have a pretty long line that I've broken up. We have the center, x and y. Well, I guess we could just say center.x like that. Must be, well, this is not a declaration. There we go. And we'll go ahead and rename all of these. Well, this, so min x and y, this can be collapsed down, which is, I think that's what he was saying. Yeah, so min, instead of min x, can be center minus 0.5 times that. And then we can do the same thing for max, but we add 0.5, and then all of this can go away. And then on the draw call, let's go ahead and break this up. Although I think I could probably just as soon make RGB be a vector 3, and then these will just take the min and the max without those accesses. And then if I rebuild this, we're still good to go. As boring as it is to just move from room to room, it is still somehow satisfying. Probably just because I know, like, I've done this all myself with obviously all this direction from Casey, but it's fun.
Vectors basically everywhere else. So this min, right? This min could easily be computed basically like that. The only question is, I need this tile side in pixels as one. So this is basically tile side is its own vector, like so. There we go. And so tile side and the map.
Okay, so he's actually taking this here, and yeah, I can just, it's going to do the same thing, right? Where I can splat that value into the vector 2, and that is looking much better. What's going on with this? What did I do there? Oh, I copied that whole line. Okay, yeah, that's not what I wanted to do. So yeah, we get our min, and now like it's just easier just by looking at the code to understand what the heck is going on. We're going from the center of the screen out the size of a tile to get the min and max values to draw the tile as a rectangle. Don't have all this math, all this all the lower level details of the math to kind of get in my headspace and force me to think about them, just to be able to read the code. Yeah, does he do this in one line? Well, he's okay. So when he initializes center, actually he does it like this, which I guess makes more sense. This is how I actually want to do this. I'm using that beaver operator. Or is it gopher operator? Is that what they call it? Is that what the Go people call it? Do they call this like the gopher operator? I have no idea. Do the same thing over here. I'm used to doing it this way because that's just, you know, what I did for months writing Zig. Well, will this just splat? Expected 2 values. Yeah, so I can't splat that way using the gopher operator. I basically know enough to make Flappy Bird or Geometry Dash. Yeah, and you know, if I was so inclined, that's what I would go and do. But that's, you know, maybe my ambitions are just too much. Maybe I aspire to do too much, you know, as like a first game. But I want to be able to have a much bigger tool set to work with and be like, you know, I have a bunch of different ideas. I have a bunch of different themes that I want to play with, but I have no idea what is even possible. What are all the ways I can bring those ideas to life until I go and you know, at least work up to the point where we get through like the OpenGL stuff. I think that's where I'll start to kind of branch off and experiment a lot more, because at that point I think he's also done some animation and some particle effects and things like that. Yeah, and you know, maybe I'll branch off sooner than that and do like a little game jam type thing rather than just continuing to do this. I've struggled with that. It's just easy to follow along with what he's doing for the time being, until I get to that point where I'm like, okay, like what if I just, you know, kind of carve out a new path in the jungle for myself and see like, what does it look like to take what we've added so far and just make like a, not even, I mean, we could do like a Flappy Bird clone on stream. We could also do like a Tetris or something, and that would actually force me to, you know, think for myself, really. But part of what I'm still doing, right, is learning Odin too, and learning all of the capabilities. I think I'm constantly torn in 2 directions. One is that like I do want to go and do my own thing. I want to go and build my own thing and have it, you know, bring my own ideas to life. At the same time, I don't want to struggle terribly to figure out how to do something in Odin and then figure out that there was this much better way to do it. And I think by going through this stuff with Casey and figuring out, it's going to expose me to doing research on how to do certain things in Odin that I wouldn't necessarily be able to, I wouldn't come across it organically, or coming across these, how to do these things in Odin organically would take much more time than just following, you know, this well-trodden path. So not that this isn't a time-consuming way as well, but it's a much more focused, and it does expose me more to, I was just listening to somebody else talk about this. It's this idea more and more that I hear that so much of our culture now, and I mean specifically in the West, we are very inclined to pay attention to the details, and we want something empirical that can give us like the answer. Like we're always trying to find like the answer, and we think that there's going to be a paper and some empirical way to come across it, but you can't always get that. And in fact, much of the way the world works actually does not involve an empirical thing that you can point to and say like, look, this is the data, this is the evidence. And again, the example that I've used and I've heard other people use, including Casey, I think, at one point, is that, again, you can break down all of the musical notes in a piece, and you can figure out all that goes into that, the key that it's in, the modes that it uses, the tempo, you know, the time signature, like all these things. But that still does not articulate the sensation that is evoked when you hear the music. the end result is much more than the sum of its parts. And you see that. I see that watching Casey program. Like watching him program has definitely taught me more about how just I am inclined to start doing things, and also just talking through things. One thing that I think is already providing a benefit to me doing this on stream as opposed to just silently doing it, on my own time, is I'm rubber ducking things out loud a lot more by virtue of the fact that I kind of have to make the stream at least somewhat engaging. However, kind of too detailed things may or may not get at times. Hopefully it'll be a little bit more organic as time goes on, especially when I can get into my own train of thought and start doing things more for myself. But anyway, not to get too sidetracked, but yeah, we've already made plenty of progress, and it's only been a couple weeks. So I think like a couple months in, and we'll get to some place more and more special. But it takes time. It takes hard work. It's not going to happen overnight. So I was thinking about this as I was just rambling on about all this stuff, and I was wondering, isn't there like a splat? I kind of want to see if there's anything in the Odin docs about splatting. Can I splat? How about in the overview? Splat? No. So, interesting. Well, I thought there would have been at least something. I bet there's like an answer on the Discord, but all I was looking for is like something that can let me, because Odin is doing something rather implicit, which is very much not how Zig works, right? Like everything is so explicit in Zig, and they do have like a splat built in for vectors, and then like on my vector classes, like on my vec2, I would call splat here, right? But this is implicitly setting this, and I was just wondering if there's another way to do this, like so. Like if I had like a v2, like a, some kind of splat directive or something that I could use. But this is still fine. It's just, I was just curious about that. So something that I have to look into for myself at some point.
Max will also be outside. There we go. Cleans that up a little bit. And the tile side and pixels we actually probably almost always use in this way. We almost always use it as a vector too. We could collapse a lot of this stuff down to vector, but still. And so then our draw rectangle call, we could also do the exact same thing.
Hold on.
But still. And so then our draw rectangle call with vector 2, we could collapse.
So, I did this wrong. I don't know how I did this or why I did this way, but this was supposed to be 0.5, right? And that's truncating to an integer, which is not good. So, yeah. How did that happen? I don't know why I did that. I guess I yanked this at some point. But wasn't I building it and wasn't it working just fine? That's really weird. I don't understand where that came from, other than I just must have yanked the wrong thing.
A lot of this stuff down to vector, but still. And so then our draw rectangle call, we could also...
Yeah, I don't think he changed anything there. It's just I have to narrow my code out here a lot more than he does because I'm all zoomed in.
Also do the exact same thing. We could start taking points there as well. We could...
Yeah, so basically, like I was saying a few minutes ago, we can go ahead and say that the min is going to be vector 2, and then the max is going to be vector 2. In fact, I can do it this way. And then we can just do that. Where did this space come from? Consequence of my going off on tangents and rambling is I guess I just make changes and I leave all of these weird artifacts everywhere in the code, which is not what I like to see. Maybe I just made that, right? And I wasn't even, like, I was looking, but I wasn't really paying attention because I was just trying to get to the end result. And now we have to go and update these. Change this to be min, and then that can just be the max. That'll fix that call. We still have this one here. Will this just implicitly splat a 0 vector 2? Only one way to find out, I guess. It does. All right, so min, when I call this here, is just being splatted to 0. Neat. And then over here, player left and player top make up the min. And then this big old chunk of code represents the max, right? Yep. Off we go. Feels good to make a bunch of changes and not have things blow up like they were doing pretty much every single stream last week. Not bad.
Basically say, all right, we've got our vmin, something like that, and our vmax, right? And that makes that function a lot easier to read now too. And so in here, when we're actually doing the rounding, we could just go ahead and do it out like that. And that way now people who call us don't have any trouble. It's no harder for us to deal with, so we're all good. And then this just takes min and max like that. What did I do? Oh, here we go. And so this one, let's see, this is player left and player top. So this is like basically player left top. We can now basically say, we can just say like that, right? And it looks like we are out of time. So there's our player left top. And then here we've actually got a thing where I guess that's our player left top plus this other vector here. And so we could actually say player width height, right? Is actually going to be another vector here that we can define, like so. Player width, player height. And then we can actually just say it's player left top plus meters to pixels times player width height. Right? And basically, you can see how we turn that into a nice vector equation there by just saying, well, meters to pixels, we were multiplying everything by that, so now we just kind of fold that into a multiply.
Okay, so that does look a bit different from how I did things. Looks like we can clean that up just a tad. So, like you said, player left top is just going to be this. And then this business, yeah, so instead of it being like player width height, we can say like player dim, right? Where else are these used, I wonder? Literally nowhere else. So we could actually do this, right? Player dim is a vector 2. I think I've got random places in my code where I'm leaving a space after the type, and then other places where I'm not. I wonder, like, I'm so OCD, I just want to know what is the convention, so I can just stick to that convention. Oh yeah, well I guess that's the reason why that won't work, huh? Because we don't know the player height. We can just say that, right? And also width is going to be first, So yeah, let's just do this. And then player width down here. Oh no, we do need that. I don't know why I didn't see that before. Okay, well. Yeah, we could just say player dim.x, but that feels kind of clunky. Let's just let's not do that. Let's just say that this is the player width, like that, and then this can be that. And then over here, we just say yeah, that's not quite. Well, okay, yeah, that's what he does. So we already have the player dim. And then over here, takes the player left top and adds meters to pixels to convert it to pixel space times the player dim, just like that. I think that'll work. Success yet again. Cool.
And again, we're just kind of folding things down. Really pretty straightforward stuff. We're coming to the end of the stream here, so I got to stop. But let's see, what did I do there that I should not have done? Cannot convert from initializer list to real 32. Oh, right, these guys are supposed to be vector 2s. So there we go. And again, we haven't, like you can see, we haven't changed anything. It's all working exactly the way that it was. No real changes. And so really all we're starting to do is start to fold that code down into something that's a little more concise and also helps us avoid the typos. The more we can sort of compress things down into logical objects like that, or we've kind of, and I might say objects, I mean mathematical objects, not programming objects, just to be clear. Although you could think of them as programming objects as well. I mean, this is, despite the fact that it's not in a class, right, it certainly is an object-y sort of thing. For those of you who like object-oriented programming, hopefully that's something that would be relatively happy. I mean, I guess you probably wouldn't like the fact that I've got my x and y sitting out there instead of being like protected or in the private section or something like this. But at the same time, it's like, yeah, you know, it's the kind of thing you might think about as an object in programming as well, in the sense that it's a bundle of things together that we're kind of moving around and thinking about as a unit, right? And so that's basically what we've got. I will go ahead and go over to the Q&A now, rather than continuing to go through and start to compress this stuff down further, even though there's a lot of things we could do now that we finally have a vector 2 class, even though it only has addition and subtraction in it and some multiplication by a scalar. There's still a ton of code that we can start to collapse now that we've got that. And so maybe that's something that I'll pick up again tomorrow, and we'll talk about the dot product and the cross product at that time. For now, let's go ahead and I'll turn on the Q&A. Please prefix your questions with.
All right, so he's just going to jump into the Q&A here, and I would like to sit in and listen to him, but I have more errands to run, and 5 o'clock is coming up, so I want to try and knock those out as fast as I can. But yeah, this was like a day that I was looking forward to in this sort of series for pretty much since I started working with Odin. I wanted to see how this would play out and how much easier it would be, or maybe it wouldn't turn out to be all that easy. I got pretty upset with myself once the bitmap loading stuff started causing all these issues, and I was like, you know, hey, I'm swizzling stuff, and it totally was not creating the result I expected. I was like, man, maybe this isn't going to be any easier. Maybe it is going to be harder. But I was just owed to some bad assumptions on my part, which is bound to happen. I think I said this yesterday, but I find that is just how it goes, right? With learning anything new, figuring out how to do something that you haven't had to do before. You make some assumptions, and then you go and prove those right or wrong. And if they're wrong, well, you got some work to do to come up with a new understanding of what's going on. But pretty sweet. So like everything else here, right? Like all these draw bitmap calls, instead of having like this align X and Y on the hero bitmaps. Well, that's an int, and I think if I remember right, the way Casey does this is he makes it like, an align vector, but he calls it like a v2i or something like that, which would mean in the math here we'd have like a v2i, and it would be like that, i32, or I guess it would be more int, vector of ints. I think we might go with i32 because I think int resolves to a 64 bit wide, right? Integer. So yeah, I'll probably just do that. I was using the vec sort of nomenclature in Zig just because that's what I had seen elsewhere, but I kind of like the more abridged style here with v2, v3, v2i, and that's just because that's like what types look like when you're dealing with like floats and ints. I got my f32s, I got my v2s. I don't know. So probably something like that, right? And so it'll just start to go. It'll go a lot faster because a lot of that is just going to be dropping in vector code where we have all of this X and Y decoupled code. But thanks for hanging in there with me and watching me enjoy Odin's array programming. Hopefully we'll pick up some real speed here. We're already going to start off on day 30, or not 30, we're in the 40s now. Day 43, we'll start getting into some equations of motion, it looks like. So looking forward to it. Have a good rest of your night, and I'll see you tomorrow.